So let's take a look. The section 1.1 definition and terminology. Okay, so let's take a look. The first definition going to be a differential equation. What is differential equation? Definition. Differential equation. An equation containing the derivatives of one or more dependent variables with respect to one or more independent variables. Okay, so that's the first definition. Here we have two important variables. One is dependent variables, and here is independent variables. Okay, independent variables. Now, let's take a look. For the differential equations, we also have ordinary differential equation and partial differential equation. Let's take a look. For the ordinary differential equations, we call it ODE. Okay. Now let's take a look. The definition for the ODE. An equation contains only ordinary derivatives of one or more functions with respect to a single independent variable. Okay, so the keywords for the ODE is what? ODE, we have one or more functions, okay, with respect to what? a single independent variable. That's very important, the keywords. A single independent variable. For the dependent, we can have one or more functions. Okay, one or more functions. Let's take a look. For example, for the ODE, we usually use this symbol dy over dx. Okay, and of course, you guys, if you learned the derivative from your calculus, you should be very familiar with this symbol. We use here, y is what? Dependent. Variable. And x is what? Is independent. Variable, right? Independent variable. So we basically here we only have what? We only have dy over dx, and we can write down a function like that. Equals 0, and we call this one as ODE y, because we can see here we have only one independent variable, or one single independent variable based on the definition, right? Because the denominator is independent variables. Here we have only one independent variable. So that means that is ODE. Okay, ODE. Now let's take a look. Another terminology we called partial differential equation. Partial differential equation. Of course, we call it PDE. Okay, now let's take a look in the definition. An equation contains only partial derivatives of one or more functions with respect to two or more independent variable. Okay, independent variables. So let's take a look at the keywords. Here, of course, did you see it? We have very important terminology. Two or more independent variables, okay? And of course, I'm gonna give you guys an example. What is partial differential equation? For example, I write down this guy, partial y over partial t, partial y over partial x equals 0. Okay, and for the partial differential equation, we use this part. Looks like a little bit like alpha, right? Alpha. So we indicate this guy is a partial derivative. Okay, partial derivative, like alpha, right? Partial y over partial t, partial y over partial x. And this guy is a PDE. Why is that? Now let's take a look the denominator. Because denominator have partial t, we have one, here we have one independent variable. Here is another one, right? So we have two independent variable. That means what? That is partial differential equation, or PDE. Okay, PDE. And you can compare it. For this equation, we only have one independent variable. Here we have two, t and x. Okay, t and x. Now I'm gonna give you guys an example. Let you guys check. So let's take a look. Now, you tell me, is that a ODE or PDE? Is that ODE or PDE? PDE? ODE? It's ODE, right? Because what? Take a look at the derivative. Here we have only one independent variable. So that means it's ODE. Definitely it's ODE, okay? Now let's take a look at another one. How about this one? Is ODE or PDE? Guys, it's ODE or PDE? PDE? Agree or not? It's ODE. Why is that? Check the independent variable. Here, independent variable just x. So only one variable. So that is ODE. Okay, just check the number of variables. If that's only one independent variable, that means it's ODE. Okay. So here still ODE, because we only found one independent variable. That is x. Okay. Now let's check another one. How about this guy? ODE or PDE? ODE or PDE? ODE, right? Because in the denominator, we only found one variable, that is t. Do you know the definition? What is independent variable? What is dependent variable? In the denominator, we count it as independent variables, right? That's the definition. In the numerator, we count here is dependent variable, right? So here, it's very clearly in the denominator, we have t variables, only one, right? So that is ODE. Is that clear? Now I have a question. How many dependent variable? 2, right? But the dependent variable, the number of dependent variable have nothing to do with the PDE or ODE. Only the independent variable matters. Okay. Very good. So now let's take a look at another one. D. How about this guy? ODE or PDE? PDE, right? We have 2 independent variable, X and Y. So that is PDE. How about this guy? PDE or ODE? ODE? PDE, right? Because we can see in the denominator, here one independent variable, here we found another one. X and T, right? So PDE. That's it. Just check the denominator. If there is only one single independent variable, that is ODE. If that's greater or than or equal to 2, that means that is PDE. Okay, that's it. That's the definition. Or you can use the simple way. If you see next time, if you see a function that is a partial, did you see the partial u over partial x? That is PDE. If you see the function that represent as what? Represent as dy over d, that is ODE, okay? That's the easiest way to tell. But I want you guys to know how the ODE and PDE is defined. It's based on the independent variables, okay? Based on the independent variables. Okay, now let's continue. So we defined the ODE and the PDE. Now we're gonna define the order. Okay, the order of the PDE or ODE. The order of a differential equation is the order of the highest derivative in the equation. Okay, so let's take a look. The definition of the order of a differential equation is the highest derivative. Okay, highest derivative. Let's take a look. An example. For example, is here. Okay, so d squared y over dx squared plus 5 dy over dx equals 2. So now, how to find the order of this differential equation? Okay, so let's check the first term. The first term, d2y dx squared can be written down as d over dx dy over dx, right? Basically, we do the derivative twice for the with respect to the variable x, right? So that means we have second derivative, and based on definition, you know, it's about the order of the highest derivative. So here is we have second derivative. Okay, so that means here we have the order of differential equation is 2, right? Order is 2. Okay, and here just 1. We do the derivative once, right? Once, so it's 1. So highest means we need to find out how many derivatives with respect to x. Here we can know there is a second derivative. After we do the first derivative, we're going to do the derivative again. So we know that is 2, right? 2. Okay, now let's take a look at another one. What is the order of this differential equation? That is cubic. What is the order of these differential equations? 3? Is 2 or 3? 3. Okay. So the answer is 2. Why is that? Take a look. This one, we only do the derivative once. And here is a power. We only consider how many times we do the derivative. We don't care about the power. Okay, power. Okay, whatever that is square or 100, we only do the derivative once. So we only count this guy as 1, right? As 1. We do the derivative once for this term. However, for this term, we do the derivative twice. So that means the order is 2, not 3. Based on definition, we see the highest derivative, right? It's not the highest power, right? So be careful of the definition. Okay, and of course, people can say that is second order differential equation, or ODE, second order ODE, because that is one variable, right? One variable. Now let's take a look at another one. Example 3. How about this guy? What's the order? 4, right? 4, right? Agree? Very good. So we can tell this guy is second order. This guy is fourth order. Okay, fourth order. So the highest gonna be 4. So it's fourth order. And we can tell that is PDE, right? Fourth order PDE. Okay. And we can apply to nth order. Nth order. Okay. So let's take a look. The nth order ODE. Okay, we define nth order ODE. We write down the nth ODE is here. And in this function, there's a big function. Inside, we have first derivative, second derivative until nth, that is nth derivative. So we call it nth order ODE. And be careful, here the derivative only respect to one variable, that is x. Only one independent variables. So we call it ODE. Okay, and here we have nth derivative, so we call it nth order. Okay, so that's the definition for nth order. And let's take a look the other definition. Okay, so let's take a look. If f is linear in y prime then we call this ODE star is linear in the variable y, okay? And we can write down the linear equation like that. Like that. Take a look. The linear equation anx to the power yn anx to the power n minus 1 y prime a0 x y equals gx. And be careful, we call this one is a linear equation. That's the definition for the linear equation. And be careful when you take a look this expression or this equation, you can tell here for the coefficient of the y, here's anx, an minus 1x. And we have the until a1 and a0. And all these coefficients are the function of x or constant. Okay. So this A0 blah, blah, blah. A function of x or constant. That's very important. Okay. So this if coefficient can be only be a function of x or constant. Constant. Okay. And if A0x is y, that means this is not a linear equation. Okay. So if A1x equals y, that's wrong. It's only a function of x, nothing to do with other variables. Okay, that's a requirement for the linear equation. Now let's take a look a specific an example. If n equals 1, A1x. So n equals 1, that means we only consider this term, right? We have 1. Or we can say here is 1. So first derivative. So first derivative going to be these two terms. Okay. And let's take a look for this guy. We can call this guy as a linear equation. Very good. And what is the order? That is first derivative. So that means first order ODE, right? ODE. And if n equals 2, that means we have second derivative, right? If n equals 2, we have second derivative. Now we can write down as this one, A2x and we call it linear second order ODE. Okay, second order ODE. Now I want you guys to take a look at cases that you guys tried based on this definition. Is this one a linear or nonlinear? That's the first question. Is that a linear function or nonlinear? Linear, right? Because what? So check the coefficient for the y. So second derivative, here coefficient is 1. The first derivative of y is -2. And here the y has 1. And the right side, that is 0, right? That is gx. So it's a constant, right? Constant. So a function of x or constant, based on definition, that is linear. Very clearly, okay? Because the coefficient is 1, -2, 1. Here is a 0. Gx can be 0, okay? So it's a linear, very good. And we know here the highest derivative, that is second derivative. So second order, ODE, right? ODE. Now let's take a look another one. This one going to be a tough one. How about this one? Is that a linear or nonlinear? Linear. Okay, very good. So the first of all, I would like to transform it because this time like that, right? We can write down like that. Then we compare the formula. Here, right-hand side is gx is a function of x, and left-hand side is about the derivative and the y, all about the y. Okay, so take a look here. The second derivative we have coefficient is x, and the first derivative that is 3x is a function of 3x. How about this time? Okay. So let's take a look. Here is a second derivative. Here, a2x is a x, a1x is 3x. And here we don't have a y term. That means what? A0x equals 0, right? It's a constant. 0 is a constant, right? 0 times y is 0. So you don't show it here. And the gx is x to the power x. So that is exactly linear second order ODE, right? Is that clear? Compare the coefficients. That coefficient should be a function of x or constant, and keep the x tends to the right hand side. That is gx, right? Gx. Now, let me give you guys this one, and this one is pretty tough. Okay, pretty tough. How about this one? Is that linear or nonlinear? Linear or nonlinear? You agree? This is nonlinear. Why is that? Check this formula. Yes, clearly is the first order, right? First order. So for the first order, a1x is 1 minus y. And that is not a function of x. It's a function of y, right? And a0xy, the coefficient is 2. That is constant. That's right. And the gx is e to the power x. That's a function of x. This one is not a function of x. Okay, so that is nonlinear. And of course, that is first order ODE. Okay, nonlinear. Okay, nonlinear. Now let's take a look at another one. Sine y equals 0. Okay. Now I have a question: is it linear or nonlinear? Good job. Nonlinear. Take a look at the definition. Again, let's take a look at the definition. It's very clear here is second order. So the a2x coefficient of this derivative, a2x equals 1. And we don't find the first derivative, so we can say a1x equals 0. And here we require y. Why we require y? Here's sine y. It's clearly not linear. Okay, sine y is a non-linear term. Okay, non-linear term. So this is non-linear. Of course, this is second order ODE. Okay, the last one. We have how about this one? Think about it. Lacey, could you type your name in the chat? Type your name in the chat. Thank you, Lacey. Is it linear or non-linear? Do you agree or not? Linear? That is non-linear. Why is that? I'm going to show you. Take a look at the definition. Although that is fourth order, right? Fourth order. This is a linear term, obviously, because the coefficient of the fourth order term is 0. Okay, is 0. Oh, it's 1. Sorry, that is constant. How about this term? This term can be written down as like that. Do you guys agree? Y times y. So the coefficient of y is y. That is not a function of x. So it's non-linear. Is that clear? We always require that coefficient of y, or the first derivative, nth derivative, is a function of x or constant. Right? So here is not a constant. It's a function of y. Okay. So non-linear, fourth order ODE. That's it.